In this video, I'm going to demonstrate the steps that are in part 2 of the process of porting code out of your con program into an HTML document so that you can run the animation on a web page. And just as a quick reminder, this is the program that we're porting, the one that draws this galaxy spiral. And this is where we left off at the end of part 1. This is the state of our code. So the first thing in the process is to look for any frame rate commands that might have been in your program in the con code. This Galaxy program doesn't happen to have one, so we don't need to do anything about that. The next thing to look for is where the shapes are drawn and convert the processing.js command into a JavaScript command. In this program, there is one line of code for drawing a shape. In this case, it's drawing a rectangle with coordinates x, y, and then the size, the height, or the width and the height of 3 pixels. And just to make this easier for myself, I have a document open here in Notepad that has some sample code that I can use. And I actually want to change this from a rectangle to an ellipse or a circle. So I'm going to go here to the shapes demo document where I draw some shapes. I could choose to use a rectangle or a circle. I'm going to choose the circle and just copy these lines of code and paste them right here under this. I still need the original command as a reference. So the line width command actually turns out to be not necessary. We don't want a fat border around our circle. So using the original command as a reference, we'll change the information here, the parameters inside the arc command, and for the XY coordinate we'll just use the variables x and y, and for the radius, which controls the size of the shape that we're drawing, we'll use 3 since that's what was used in the original. And now that we've copied that information in, we'll delete this. So we've completed that step of converting the ellipse or rect command into JavaScript. And then we look to see if there's any stroke or fill style commands, which would be up here in the global variables from the con code. This fill command will not work. Also, this no stroke command will not work. The no stroke command essentially means that we want the shape and its border to be the same color. So we can do that down in here. So fill is this color here, this RGB color, 230, 230, 145. Let's put a fill style command here. If we make the fill style and the stroke style the same, then we'll have a shape without a border. If we don't like this color, we can change it later. So let's delete that. So there are no other stroke or fill commands from the original code, so we can leave that alone. So we can consider that part done. And now the last thing that we need to do is look for any math related functions that need to be converted into a JavaScript command. And the first one here is the square root function. We'll change that to JavaScript by just adding the math dot in front of it. Same thing here with the cosine command and the sine command. And that should do it for us to be able to have the Galaxy animation run in a web page. So I'm going to do a save as here to leave the original shell.html as it was, and I'm going to save it as shell test. So now that we've saved this, let's test it by running it in Chrome. Well, it looks like we have an animation running, but it's not behaving exactly the way we want. We want the background, or we want the drawing to clear inside of every loop that's run instead of just drawing the circles on top of each other. In the Khan Academy program, they do this by using this background command inside the loop, so that after it draws all the shapes here in the for loop, it clears the screen before it draws the next set of shapes. We can do the same thing here, but with a different command. We'll do this outside of the for loop, but inside of the render function, or which is our draw loop, by typing in the canvas.width equals canvas.width. That is a way of redrawing the canvas and clearing out whatever's already on it. So now let's go back and refresh the web page. Okay, so it's working, but the animation speed is pretty fast. So there's a couple of ways we can control that. Here in the set interval command, this tells us how many thousandths of a second to wait between each time it runs this render loop. This is the speed parameter. Every 25 thousandths of a second, it runs the render loop, the render function as a loop. So we can play around with this, and if we want to slow it down, we make this number bigger so that it's not every thousandth of a, or every 25 thousandth of a second. We can make it every 250 thousandth of a second. And go back and see and refresh and see if that slows it down. Well, it slows it down, but it's really jerky. So another thing that we can do is change this increment. So not getting too much into the actual math of how this is done, we do know that the reason that this is animated is because the drawing is that there's an increment, an incremental change that's made, and this variable here is where the increment takes place. It increases the angle by 1/100th of a point each time. If we want to make it smoother, we can make the increment smaller. I have a feeling it's going to need to be much smaller. So let's save that and go back and refresh it. Okay, so now it's a little smoother, but it's too slow. Let's go back one more time. Change this back to 25 thousandths and refresh it. That's much better. So by adjusting the amount of the increment, which moving stuff from Khan Academy to HTML, it's probably a good idea to go for smaller increments so you can have a smoother animation, and that's what we had to do here. So that completes the process of porting the code from Khan Academy program into an HTML document that'll run on a web browser.